first I'm going to highlight these words right here. An extraneous root is something that appears to be an answer, but in checking it does not actually work. And this one is interesting as well because you have two square roots. And the next question we're going to do after this one, I'm going to show you that if you have more than one square root, you do it systematically. You get one by itself and square both sides to get rid of it. And sometimes that'll get rid of both of them. Like this one, do you see if you square both sides, you'll get rid of all the square roots. And sometimes it won't. And you'll have to do that process more than once. So I'll give you an example of that after this. But on this one, if I have, this is all by itself. This is definitely all by itself. So I can square both sides and wonderfully, this would go away on that side and this would go away on the other side. Now you have like terms. Let's get our x's on one side. I'm going to get my x's on this side. So if I subtract x, I'd just be left with x. I'm going to add 5 to both sides and I get x equals minus 2. And things seem very good. However, when I check my left side and my right side, if these numbers are different, or if you are forced to take the square root of a negative, that's not possible, and that would be bad. So I'm going to check. If I plug in negative 2 on the left side, I'd have 2 times negative 2 minus 5. And if I plug in negative 2 on the right side, I'd have negative 2 minus 7. Well, 2 times negative 2 is negative 4 minus 5 is negative 9. And this side is negative 9. They look the same. However, both of these are not possible. You're not allowed to square root negative 9. At least not in the mathematics that we do. There's a whole branch of mathematics which says if we make a new rule, you're allowed to square root negative numbers.
What's the rule?
You have to invent a new number. And the new number you invent is called an imaginary number. This sounds like I'm making this stuff up, right? This is actually true. The imaginary number is represented by the letter I. And all you say is, if we let I equal negative, the square root of negative 1, now we can do math. Do you know what the answer to the square root of negative 9 is?
I.
3i. The square root of 9 is 3, and the square root of negative 1 is I. It really sounds like I'm making this up, right? Imaginary numbers. You can turn your calculator, just so you see that I'm not actually lying here. Look at this. I'll go to my graphing calculator. I'm going to go to its mode, and I'm going to turn on, I'm going to get out of real numbers, and I'm going to enter into imaginary numbers, and push enter. And then I'm going to do the square root of negative 9. And I get 3i. I didn't make this up. It sure sounded like, right? Now you get this joke that I have on my wall. See? Get it? Oh. I love math, all math, all math, all. Okay? But we don't have to do imaginary number math. So I'm going to take my calculator and put it back to real numbers. So everything is okay. We do this, we get an error. We're happy again. So you would have to take this x equals 2, put an x through it. You can even underneath write extraneous root. So we will sometimes get extraneous roots because we get a square root of a negative number. That's never possible with real numbers. And so we have to say not possible, extraneous root. In imaginary numbers, this is possible. Some real life problems in the world can only be solved by working with imaginary numbers for a while and then coming back to real life and your problem is solvable. So there's a reason that they had to invent imaginary numbers. Some people call them complex numbers because imaginary doesn't sound as good. Complex sounds more involved. Okay? For this one, circle question 10. And now you can work on 7, 9, and 10 for a bit.